Good morning, sir. Respected jury members. Today, our paper ID is 2086, and the title of the paper is Prediction of Omicron Virus Data Analytics Using Extended Convolutional Neural Networks Technique. Myself, Dr. Asadi, and my colleagues are Anand Kumar Gupta, Tarakeshwar Barua, and Kamal Kant Hiran. This is the content today I would like to explain: abstract, introduction, literature review, existing system, proposed system, implementation, results, conclusion, and followed by the references. Coming to abstract, Omicron is a variant of SARS-CoV-2 first reported to the World Health Organization by the Network for the Genomic Surveillance in South Africa on 24th November 2021. So Omicron is an extension of COVID-19 virus, and in the existing system we are using convolutional neural networks technique. There are some drawbacks are available, and this Omicron symptoms like runny nose, headache, fatigue, sneezing and sore throat. In order to avoid the existing system drawbacks, we are proposed technique is extended convolutional neural network with different frameworks we have applied on this research article like VGG16, ResNet, GoogleNet, Keras, PyTorch and TensorFlow. That's why we used to call it as extended convolutional neural network. The proposed research method completed Omicron detection with an accuracy of 99.25 on public available data sets such as Kaggle and GitHub and also UCI repositories. Coming to introduction, since the Omicron variant emerged in the late 2021, several subvariants have been observed, and we have seen strain coronavirus and COVID-19 virus. Those viruses are before identified this Omicron virus. According to CDC, the Omicron variant spreads more easily than the original SARS-CoV-2, that is COVID-19 virus, and the Delta variant. Currently, there are no specific drugs and medication are available to prevent or treat Omicron variant of COVID-19. So, for our research article, we have done tremendous literature review, and we have collected more than 50 papers. Amongst, we have chosen the first base paper for our research article is identified as author name called Aizaz Ahmad. He has been published an efficient CNN model for COVID-19 disease detection based on X-ray image classification at a reputed journal called Hindawi Complexity. According to Aizaz Ahmad, in this paper they have used convolutional neural network architecture, that is deep CNN, they have applied on the X-ray image classification, but the drawbacks like less accuracy and high time complexity we have observed, and that's why we would like to extend our research on this topic. The pre-processing stages of the data sets performed in this study include data set balancing, medical experts, image analysis and data augmentation. This is the input data set we have taken from the Kaggle and GitHub and UCI repositories. And the existing system we have applied artificial neural networks and convolutional neural networks. We have identified from the literature review there are various drawbacks like less accuracy, less performance, high error rate. That's why we are, in order to avoid the existing drawbacks, we are proposing a technique is called extended convolutional neural network by integration of various frameworks such as VGG16, ResNet, GoogleNet and TensorFlow, Keras, PyTorch. These are the frameworks we have applied with CNN. That's why we used to call extended convolutional neural networks. Finally, we achieved various advantages such as high accuracy, low time complexity, high performance, reduced computational cost. And this is the algorithm we have applied on X-ray image data sets, that is ECNN. First step, we are uploading the required libraries. Then we are performing pre-processing of the data set in order to eliminate redundant data, noisy data, inconsistent data by applying pre-processing techniques like binning and box plot technique. Then we combined with CNN with extended neurons. Then we have applied a tenfold cross validation with two classes, that is two class classification. Then we have imported Keras deep learning library and reset all parameters such as accuracy and data set size and Linux environment. Those are the parameters we have chosen in order to execute this ECNN. Then enhancing this ECNN part and about regulations of loss calculation function, enhancement of yield part of tenfolded with two classes, accumulate the ECNN parameters, adjusting the ECNN in the preparation model, and finally load the Omicron disease infection image data, and we have achieved 99.25% accuracy. And finally we stop this algorithm once we got the required output. This is the proposed architecture of extended convolutional neural network. We have taken CT scan image as a data set, and we have applied various steps in ECC algorithm such as image augmentation, pre-processing. We have applied mathematical convolutional layer, that is 3 by 3 matrix. Then we have applied convolutional two-dimensional array. Then we have applied dropout layer. Then we have again applied activation function called softmax in the flattened layer. And in order to increase the accuracy, we have incorporated with the dense layer, and we got required output by applying this activation function. Finally, we have classified into two types called negative class and positive class. And these are the results we have achieved through this extended convolutional neural networks on Omicron CT scan images. If you see the first result, we have compared with the accuracy versus loss, and we got very good accuracy. In the second result, we have compared with the three parameters called epochs, loss, accuracy. In the third result graph, we have compared with the value accuracy versus value loss. In the final one, we have compared with the number of epochs versus loss. And this is the conclusion we have achieved on Omicron CT scan images. Accuracy is 99.25%, and the proposed prototype in the present research is to be able to effectively predict and detect all cases of variant of COVID-19 with greater competency. And the future work of this one, if you integrate with the hybrid technologies of deep learning techniques, so that we can implement in the real-time environment. These are the references we have collected from the various reputed journals, and we have applied on our research article. Thank you, sir, for giving me this wonderful opportunity.